Hello friend, welcome back to my channel Crew Electric. In this video, today we see what is the power factor and what is the power factor triangle, what is the impedance triangle. Let us see. The first question, what is the power factor? So simple, if you want to give definition, then you can say that it is the cosine angle between the voltage and current. That is the power factor. And if you want to define the angle between the voltage and current, that is the phi. That's why the power factor is cos phi. So here this reference lines indicate the voltage and this line indicate the currents. The current is somewhat lagging behind, that's why the angle is produces, and the current is lagging the angle phi from the voltage. Suppose this is due to the inductive load. Okay, so in circuit the inductance is there, that time the current is lagging. If the capacitance is there or the inductive reactance is lesser than the capacitive reactance, then the current is leading and this phi comes on the upward side. But if you convert it to the cos phi, then that value gives the power factor. Okay, let us see what is the power triangle. So in the power triangle there is three terms. One is the active power, another is the reactive power, and the third one, that is the resultant from the active power and the reactive power, that is the apparent power. So the active power, so for the pure resistive circuit that consume the active power. So if in the circuit the reactance is there, then it consumes the reactive power. So in load both resistance and reactance is there, then the power consumed by the both given as the apparent power. You can directly find out it by the Pythagoras. Okay, so you can take square of this by adding and taking square root, then you will get the kVA. Okay, same in this triangle, this is the drop due to the resistance, that is the I into R. This is the drop due to the reactance, that is the I into X, and this is the resultant or the total drop due to the both resistance and the reactance, that is the impedance. So what is the impedance? Impedance Z equal to under root R square plus X square. You can simplify this equation from this triangle. And again, the angle between the resistive drop and the total drop, that is the phi, and the cosine of that is the power factor again here in this case. So mathematically, if you want to calculate power factor, then you can calculate the power factor cos phi by the taking ratio of active power to the apparent power. Again, it's active power kW and the apparent power, that is the kVA. Again, from this triangle you can say that is the IR by IZ. Again, the II cancel out, that is the R by Z. So you can also say that the ratio of resistance to the impedance, that is the power factor. And another definition, the ratio of active power to the apparent power, that is the power factor. Now let us see what is the impedance. We already see the impedance triangle previous from the all drops, resistive drop, reactance drop, and the total circuit drop. So what is the definition? The electrical impedance is the measure of the opposition that the circuit present to a current when a voltage is applied. So that is nearly same as the resistance. So what is the resistance? Which oppose the flow of current. And what is the impedance? Whenever you give the supply and which term oppose the current. So in case of AC circuit, the impedance is there, and in case of DC circuit, only resistance is there, because this part is reactance, and that reactance is not present in the DC circuit. That is present only in AC circuit. Another definition for the impedance. Impedance is defined as the ratio of RMS value of voltage to the RMS value of current. So you can also define the RMS value ratio V by I, and you know very well V equal to I into Z. So here is the Z is the impedance. So what is the Z? Z equal to R plus or minus Jx. Then how? So whenever just you talk about the inductive circuit, that time the plus Jx is there, and in case of capacitive circuit, minus Jx is there. Why and how? Because this is the imaginary part. This term show the real part and the imaginary part. So this is the real part, that is the resistive, and that is the imaginary part. So this is the direct addition of these two vector, one vector R and another vector Gx, that results the impedance Z. Again, same case for the capacitive circuit. Sorry, this is for inductive circuit. Here is for inductive circuit and here is for the capacitive circuit. You can calculate impedance by this equation. So thank you very much. You can subscribe my channel by searching Like Tech in the YouTube and click on subscribe button. Thank you very much. Thank you for watching my video on YouTube.